Okay, well, just thought I'd have another look at the Aulis site. Could do with a bit of a chuckle. This is a Apollo 13 they're talking about here. And it says, apparently the panel separation from the craft damaged a dish on the CSM, Command Service Module, antenna, and as a result, the high gain antenna switched from narrow beam to wide beam. But the wide beam mode required that the dishes were operational, while the narrow beam could actually work with a dish not operating properly. Therefore, I'm reading this through the camera viewfinder again, therefore it is the converse that should apply. It should have switched from wide beam to narrow beam. Now, if we go and look at the actual the NASA Apollo 13 report, it says, at approximately 56 hours, the high gain antenna experienced an apparent switch from narrow to wide beam width. So it's the other way around. So the Aulis guy is saying that it switched from narrow to wide, and he thinks it should be the other way around, with a resultant temporary loss of telemetry data. This occurrence coincided with the oxygen tank pressure loss. So the panel blew off the side of the spacecraft and it damaged the high gain array, which is 4 dish antennas. Now, what this chap doesn't understand is that the 4 dish antennas, has he got a picture of it here? No. There is the 4 dish antenna array. Each dish is steerable. So when you look at the, hang on, let's just see if I can get a picture of it. Let's see if I can get a picture of it. What would that be? Well, it's pretty dark in here actually. Apollo. I can't see the keyboard. CSM. High gain antenna. Here we go. And yeah, there we go. That's probably as good an image as we're going to get. Oh, there we go. There we go. There's the 4 dishes. The Command Service Module antenna. Can we just... graphical representation might be better. Oh, there we go. So all these dishes, all these individual dish antennas, they're 31 inches in diameter. And these dishes are 31 inches in diameter. And they're all individually steered, so you can actually shape the beam. You can make it wide beam or you can make it narrow beam. So when one of the dishes got clobbered by the panel coming off the spacecraft, it would indeed have gone to wide beam. It would have indeed gone to wide beam because they wouldn't be able to steer all of the dishes to form a narrow beam. So with one of them knocked out, the beam will be wider. So this guy, like most of the people that make technical comments about this, has no idea what he's talking about. So if we go back to the Aulis site, and he says it should have switched from wide beam to the narrow beam. He's completely wrong. NASA said it switched from narrow to wide, and that's exactly what it would have done with the loss of 1 dish. So we have another clueless technical expert. Let's just see what else he's got to say here about this. See this here. Yeah, he's talking about zero optics mode circuitry. You'd really need some sort of context to understand what was going on here, so I'd have to look into it a little bit to find out what this is actually doing. I suspect, again, he's clueless, but we're looking at a motor drive, motor tachometer, so that's going to output pulses. So it's driving some gears. So basically you've got a tachometer, you've got gears, that's going to be rotating, so the tachometer is going to be sending out pulses. It's going to times those by 16, is it? Yeah. See, without knowing what this is supposed to be doing, you know, you can't really comment on that. He certainly can't comment on it. I have to have a look at the rest of the to see what the rest of it is doing. But I thought there was something else here that I thought was quite funny. Gives an it's showing a thing there with some pulses coming out of it. Something else here I thought was quite funny. I think this is it here. Again, our engineering genius says, where is the input? Where is the input? He says we've got a sine wave output, but there is no input. It says, the Apollo 13 mission report includes the schematic of a 1/2 speed resolver. But the problem with the above schematic is that if there is an output circled with red, like that, there is no input at all. An electronic interface designed to transform a transform a signal always has at least one input and one output. What he's obviously failed to notice is the 28 volts reference here, 800 hertz. So this is not DC, this is 800 hertz. So this is going to be a sine wave, 28 volts peak to peak. So there's the input signal there. And if it's a square wave and the inductors are cleaning it up and making it into a sine wave at the output, the same is still true. You've got a sine, you'd have a square wave running at 800 hertz, 28 volts peak to peak. There you go. So there's the input. See, the other thing too is that doesn't actually say, yeah it does, that says sine output. So that's what's happening there. I'm looking at this through the camera viewfinder, remember. Our engineering genius has said, right, we've got a sine wave coming out here and we've got nothing going into the circuit to produce the sine wave, and we certainly have. We have 800 hertz at 28 volts peak to peak, either sine or square going in there, and if it's a square wave the inductors would clean it up, so you have a sine wave coming out. So I don't know where this this engineer learned his engineering, but if I was him, I would seriously consider going and knocking on their door and asking for my money back. All right, well, I'll have another look at this a little bit further down and see if I can find anything else of interest, but otherwise this will just be another quickie, just having a coffee and some chalky digestives. So let's have a look at some more of this Aulis nonsense. And of course, you know, the first thing I find when looking at the Apollo 13 report, if that's the right word, is it's nonsense, absolute nonsense. Absolute nonsense. The guy's got absolutely no idea about beam width on microwave links, how that's achieved with multiple antennas, and he's got absolutely no idea about how to read a very simple circuit diagram, or a very simple schematic in this case. There's no input. Where is the input in red? Well, there's the input, Mr. Aerospace Engineer, right there. If I were you, I'd scuttle off and demand a refund. Alright, well, I hope you enjoyed that very quick video, just more all this bloody rubbish. Perhaps I'll catch you again.